In today's lesson we will be looking at the nets of 3D shapes. The net with 3D shape is what it would look like if it was opened out flat. The net can be folded up to make a 3D shape. There may also be more than one possible net for a 3D shape. For instance, with a cube there are quite a few different nets. Just a few things to remind us. Vertices or vertex means the corner of the shape. The face, so the face of a 3D shape is what shape is looking at you. So for instance, this one is a square, this is a cube. And the edge, well, that means the edge of a 3D shape. So first of all, here we have a cube. So you can see a cube, what we know of a cube, it's made up of 6 squares. So when we open it up flat, it could look something like this. Now, this square at the bottom is what we'd call the base. And it's here, this is that square. And if you imagine, we would fold this side down to give this. And we could fold the side on the right down to give this side. There's also a square at the back, so we can fold that down to give you this. And also we could fold the one at the front, which gives us this square. Now the square at the top, if you imagine you're folding this side down, well, the square at the top would also come down with it. So that's why we have this square here. So you'd fold this one up and fold that one up as well. Sometimes you will see nets with little extra parts on, like here. All that is that if you were to print it out and cut around, you would glue these flaps so they'd stick together. So next we have a cuboid. A cuboid is very similar, as we know, to a cube. It's made up of squares and rectangles. Again, we look at the base, so there's a rectangle at the base. We could fold the left side and the right side down, so you'd have the left side and the right side. This rectangle at the back could fold down here, and the one at the front would also fall down with the lid, the one at the top, coming down with it as well. So this is a triangular prism. What do you need to remember with a triangular prism? That is a triangle at the front, and there's also one at the back. And also it's made up of 3 other rectangles. So if we start with this rectangle at the bottom, because it's the base, well, that's here. And attached to that we have a triangle at the front, which is here. A triangle at the back, which is this one. And then we have a rectangle to the left of it to give you this, and a rectangle to the right of it to give you this. Next we have a square-based pyramid. Now a square-based pyramid is made up of 1 square at the base and then 4 rectangles coming off each side. So, square-based, the square is the base, and then each triangle is folded away from that square. Here's a tetrahedron. So tetrahedron is similar to a square-based pyramid, apart from it has a triangle at the bottom. So the triangle is the base, which is here. And then 3 triangles coming off it, 1 from each side. So we'd have this triangle here. We fold it down the front. You'd have 1 from this side. Fold it over here. And then the one at the back can be opened up over here. The cone, the face, the net of the cone is a little bit strange to look at. So first of all, a cone has 1 circular face at the bottom, and then it has one curved face going all the way around the circle. So we have a circle at the bottom, and if you were to open up the cone, it would look like this, with this line here going all the way around the circle. And next we have the net of a cylinder. So a cylinder is made up of a circle at the top and a circle at the bottom. So we have a circle here and a circle here. Now, if you can imagine, if you take these two circles away and you're left with this curved surface, if you were to open that up, that would actually be in the shape of a rectangle. That's why when you have a piece of paper, you could roll a piece of paper up into a tube. So it looks like a cylinder. Okay, so now we go on to our first example. And the question says, complete the table below to match the three-dimensional shape with its correct net. One has been done for you. So you can see that the cube is net B. And as I said before, not all nets look the same, and this is a good example of that. That's different to the net that we showed earlier. So next, let's have a look for the net of the cuboid. Now what do we know about a cuboid? Well, we know it's going to look fairly similar, or it is fairly similar to a cube. So we're going to have rectangles and squares. That means that it can't be A, C, D or G because they have triangles, and our cuboid does not have triangles. So it can only be E or F. And what do we say? Well, the cuboid's got to have rectangles, so the net of the cuboid is indeed F. So next we're going to look at the triangular prism. And what do we know about a triangular prism? Well, it's going to have two triangles, and it's also going to have three rectangles. So if we look at the triangles first, well, there's too many here, there's too many here, and there's too many here. So it has to be D. So we have two triangles and three rectangles. And next is asking us to look for a square-based pyramid. So square-based pyramid has a square at the bottom, at the base, and then it has four triangles. So although A and C have four triangles, there is no square there. Therefore, G has to be the net, because it has one square and four triangles. And the last one, we need to look for the net of a tetrahedron. So tetrahedron is made up of four triangles, and there's one at the base. So it can only be A or C. And actually, if you look at it, if you use your mind's eye, A can't be folded up to make a tetrahedron. Whereas C, we know this is the net for the tetrahedron, because we looked at it earlier. And the next question says that Fiona's making a box for the present. The box is a cuboid, and she draws a sketch of the net of the cuboid. So you can see we have the net of the cuboid, and there's some lengths on here. So we have 6 centimeters, a 4, a 5, a 5, and a 4. You need to write down the height, length, and width of the box. So first of all, if it was me, I would look for the base. So I would say this rectangle here is the base. Now if that's the base, that would mean that this 6 centimeters is the same here. So it's 6 centimeters here. So we could say that the length of it is 6 centimeters. And this side here, this rectangle is at the back of the cuboid, so that's going to fold up. So if it's folding up, that would mean that it's 4 centimeters high. And with this side folding up as well, you can imagine the cuboid going back 5, so it has a width of 5 centimeters as well. Okay, so the next question, it says to draw a sketch of the net of a cube. So it hasn't given us any dimensions, it doesn't say to make it 2 centimeters, so we just need to draw a sketch of the cube. Obviously you'll need to use a ruler and a pencil. So what do we know? Well, if it's a cube, each side has got to be the same length. So however big you decide to draw it, it needs to be the same length for every side you draw. So let's start by drawing the base. So we have a base which is a square. So the base is here at the bottom, if you like. So this is the base. So next we're going to draw a square at the back, so it folds down, making sure that it's the same length and the same size. Then we can draw this square at the front. We open it up from the front, making sure it's the same size. Then don't forget, when we open up the front, we can bring the lid down with it. So the lid will also go at the bottom, making sure it's the same size. We now need to draw the one on the left and the one on the right, remembering they are connected to the base. And we said this one here is our base. So you draw the one going to the right, and then you would draw the one going to the left. And that is how you draw the sketch on the net of a cube. There's no measurements involved. Okay, so the next question says that the following diagram shows a rectangular box, and we can see that the box has measurements of 6 centimeters by 2 centimeters and a height of 3 centimeters. The question asks you to draw an accurate net for this box, so that means you will need to use a ruler and a pencil when drawing. Just to make things a little bit easier for us, we could draw in a few lines so they can help us imagine what it looks like on the inside of the cuboid. So we can see that the base here measures 6 by 2. So that will be the first one we draw, making sure you use your ruler to measure the lines are correct. So we measure the base, so it's 6 centimeters across, and then it's down 2 centimeters, and on the other side we measure 2 centimeters as well. Now when you draw in this line across here, it's still a good idea to measure it to make sure it is 6 centimeters, to make sure you've drawn these lines straight, and more importantly, make sure this one is accurate as well. So that's the base. So next we can draw the shape at the back. So if we fold this back down, we can see that it needs to be 3 centimeters on each side, and we don't need to draw 6 centimeters along the bottom because the 6 centimeters is already here, but you will need the 6 centimeters for at the top. So we have 3 centimeters there, which is this line, and 3 centimeters on the other side, which is this line. And they should also be 6 centimeters apart. Again, make sure you're using your ruler to measure. Next, we will draw this side on the front. So this side would be 3 centimeters. This would also be 3 centimeters. But we don't need to draw the 6 centimeters along the bottom because that's here. But you will need it for this one at the top. So first of all we have the 3 centimeters, which is this side, and 3 centimeters, which is this side. And then with your ruler, make sure you measure and draw to make sure that is also 6 centimeters. Now when we fold the front down, we can also bring the lid down with us. So with the lid, we know it's going to be 2 centimeters because it's 2 here. It must be 2 here, which means it's going to be 2 centimeters both of these. And we know this is 6 centimeters, so that will be already here on this side, but you will need the extra 6 centimeters at the bottom. So we draw the 2 centimeters, which is this side, with the 2 centimeters on the other side, which is here, and again with your ruler making sure that's 6 centimeters. Next we need to draw this side and this side. To do that we need to use the base, because remember these are connected to the base, and we said that this shape here, this one, was our base. So if we look on the side, it's measured by 2 centimeters, so it's 2 there, it must be 2 here, and it's also going to be 3 centimeters high. Look what we've already got. Well, we know this one is already 2 centimeters, so we only need to draw the 3 centimeters coming out and then join them up to make sure they're 2 centimeters apart. So we have the 3 centimeters and the other 3 centimeters, and then with your ruler measure them to make sure that they are 2 centimeters, and we do the same on the other side. So it's 3 centimeters by 3 centimeters, and then we join them up to make sure they are 2 centimeters apart. So just a few things for this one. I have said, but it is important to use a ruler, and you know how to use your ruler, so you can't afford to make any silly mistakes. Can you please copy down all of the notes in your big book, please? Copying the examples might be a little bit tricky, but you have got a booklet at home to practice. Thank you.